Hey everyone, this is Mrs. Moriarty, and I'm here to discuss with us topic 8.10, which is all about waste reduction methods. So, a big piece of our discussion on terrestrial or land pollution we know is talking about the generation of municipal solid waste, and that can constitute many different things like food, that can be yard waste, that can be paper waste, hazardous waste, and so on. So, how do we go about reducing the amount of trash in which we generate? That is where the 3 R's, reduce, reuse, and recycle, come into play. So, this is usually a very popular phrase that's used to educate people on diverting materials from the waste stream specifically. Now, the first one, reduce, that is going to be the first choice, and that's going to be the choice that requires the least amount of energy out of the three, because this is just simply reducing the amount of goods that you consume on a daily basis. So this is just simply like reducing the amount of things that you could wind up then generating trash from. So that's where source reduction kind of comes into play. So this is an approach in waste management that seeks to kind of cut waste in general by reducing the amount of potential waste materials in early stages of design and manufacturing of goods. Source reduction can increase the energy efficiency by manufacturing less waste and minimizing them having to pay for then the disposal of those materials that are required to make whatever good they're going to make. Source reduction can also involve substituting maybe less toxic materials for others, so it can have an environmental and human health benefit. An example, right? Metal or reusable water bottles are used to reduce the use of plastic, right? Riding a bike or walking is reducing your amount of gasoline that you're using. Then looking at the second R, this is reuse. So now this is using a product and you are taking that material that was intended to be discarded and you are reusing it for another purpose. So there's really no additional energy that has to go into the making of this product, right? It just simply needs to be reused. So energy may, however, be required to prepare or transmit the object for reuse by someone or the original user, but it's not going to dedicate, obviously, as much energy as it would if you had to create the product all over again. Some examples of that can be buying secondhand clothes, using maybe old wood pallets for the newer furniture, washing plastic takeout food containers, and reusing them for the future. Now, the last R, or recycling, this is the one that's going to dedicate the most energy out of the 3R phase. This is a process in where now materials that are destined to become municipal solid waste are taken, right? They're collected, and they're converted into then raw materials and used to then produce other objects. Now, we can have two forms of recycling. One is known as a closed loop and one is known as an open loop. Closed loop recycling, right, recycles a product and then turns it into the same product over again. An open loop recycling would be recycling one product, breaking down those raw materials, and then turning those raw materials into then a different product. So some examples, glass being turned into glass once again, right? Throwing away a glass bottle but reusing it to make another glass bottle, that's closed loop. But let's say turning like plastic water bottles and turning that into a form of fabric for clothes or for jackets, that would be an example of an open loop recycling, because that plastic was once for a plastic water bottle product and then those raw materials were broken down and changed into something else. Now, this is the least sustainable of our three choices, reduce and reuse, and that's just because the amount of energy dedicated to now take those materials, break them down, transform them into something else requires a lot of time and energy. So what are then the pros and cons of the last R, recycling? Some of its pros: reduces the demand for then new materials, since we're now taking old materials and transforming them into another product. Reduces energy required to ship those said raw materials, and we know with the transportation and shipping, that's going to produce fossil fuels, so if we don't have to do that, right, it lessens our chances of that being emitted into the atmosphere. And it can help to reduce any landfill volume, right? Conserving any landfill space and reducing the need for then more landfills to put more municipal solid waste. Its cons. It can be costly and requires significant amount of energy. Cities that offer recycling services need to process the material, they need to sort the material, sell and collect the materials, and prices can change very rapidly, leading to recycled materials being oftentimes thrown away, right? A lot of people don't really understand what can be recycled and what can't be recycled, and oftentimes it takes a little bit more part on the consumer to then sort those items, so oftentimes people just don't recycle. So when citizens recycle items that shouldn't necessarily be recycled, maybe like wrappers, maybe plastics that have a lot of food residue on them, styrofoam, plastic bags, it can then increase the cost to the city to recycle because now they have to just further sort all of the recycling stream that's coming in. So an alternative here, right? So we mentioned that the 3 R's are a way in which we can kind of reduce landfill volume, reduce the trash that we generate. We know that a lot of the municipal solid waste stream is organic in nature. And so another form or an alternative that we can use to help reduce landfill volume would be to compost. So, looking at composting, it's mixtures of organic materials like food and yard waste that usually end up in a landfill decomposing over time. Here, though, in composting, we take that same kind of organic matter, right? We decompose it, right, in the presence of bacteria, and what that eventually can do over time is create an organic-rich material that we can then use for our own soils, maybe in our home, maybe school campus, office building, and so on. So what can compost do? It can reduce landfill volume, since we know a lot of what ends up in the landfill is organic in nature. It produces a valuable product. You can wind up selling that compost. And it reduces the amount of methane released by landfills. Remember, we said landfills, because they lack a lot of oxygen, they're doing anaerobic decomposition, so that produces a lot of methane, and the decomp is very slow in process. So composting at home can wind up reducing the chances of that being produced. Now, what then should be composted if you decide to do it at home? This really should be items that fall in that category of organics, so that would be vegetables, vegetable byproducts, so that could be like the skin of a fruit, could be animal manure, yard waste, grass clippings, paper fibers. All of those can wind up in your composting bin. This should be done with a proper mixture of both greens and browns, browns meaning containing heavy amounts of carbon. This should be aerated over time, so you'll oftentimes hear of people kind of like turning their compost bin. What that does is it helps to mix in oxygen, so it aerates the mixture, kind of perpetuating the decomposition that takes place with the microbes that are naturally found there. Now, some of the potential drawbacks of having composting, especially at home, if you don't really keep an eye on it and you don't really manage it very well, it can produce a very foul smell. And you do run the risk, especially if you keep it outside, of it getting into, or rodents getting into your compost bin, like raccoons, rats, and so on. So if you think back to 8.9, another aspect of our municipal solid waste stream we discussed was e-waste. We know that e-waste can pose tremendous risks to the environment and to human health because the materials that help to build the electronics can be toxic in nature, especially when leached into groundwater and soil. So can we recycle e-waste? It can be recycled and it can be reused to create new electronics. But as mentioned previously, these old electronics will most oftentimes be sent to developing nations for the recycling due to the health hazards associated with taking apart the electronics and being exposed to maybe some of the more toxic materials, a part of the electronics, especially when much older. They can be dismantled and sold to other countries, so it can be economic in value, not just environmentally. And unfortunately, too, they can be burned or dumped due to less strict environmental regulations if they wind up in developing nations and they can't quite keep up with the stream of e-waste there. And then last couple things. We said before that landfills have the potential to produce a lot of CO2, a lot of methane. So can we take that methane that it produces and turn that waste into, let's say, energy? Yes, we can. Waste can be incinerated to reduce the volume right in the landfill itself, but it can also generate electricity. Most of that waste, paper, plastic, food, contains things like hydrogen, carbon, and oxygen, so it can combust at high temperatures. And it really, for the most part, runs in the same way as some of the other fuels that we discussed in Unit 6, like coal, natural gas, and biomass. We know it can be heated, right? That heat then takes water and produces steam. That steam turns a turbine, right? Powers a generator to then produce electricity. So the methane gas produced by the decomposition in landfills can be collected using a system of pipes to then eventually generate electricity. This reduces landfill volume and winds up producing electricity without having to frack for it or mine for it. All right, folks, that brings me to the then practice FRQ. And as you'll see, this one pertains to a little bit of math. Make sure that you write your answer in the Edpuzzle and on your FRQ journal. Here in our practice FRQ, it's stated a typical landfill can accept about 2,800 tons of trash per day. Typically, 1 million tons of landfill waste can emit approximately 432,000 cubic feet of landfill gas per day, enough to produce 0.78 megawatts of electricity. Calculate how many kilowatts of electricity can 2,800 tons of trash produce. And here's just a little recall. Remember, 1 megawatt equals about 1,000 kilowatts. So if we were to solve this requires just a little bit of dimensional analysis. So we know that our typical landfill accepts about 2,800 tons per day. If we multiply that by the size of our landfill, which we said was 432,000 cubic feet of gas per day, we then take that value and we multiply it by the amount of megawatts of electricity that we know that the methane gas can produce. However, we do need to convert that value into said kilowatts. So then that's where the last and final piece comes in, and that would get us about 2.18 kilowatts. All right, everyone, that's it for our video on 8.10. If you have any questions, please leave it at the end of the video.